direction of the force. Okay. Then let's look at the rest. Then we will find out what's the force inside here. Then we can find out what according to the area we can relate it to the stress and the strain. Yeah. That would be a way for us to find out what's the P over here. That's all about force analysis.
Oh, yeah. You're right. Kan?
Us that for some of the certain cases, if it can be considered as a convention, means can be considered as a conclusion for the certain kind of conditions, which will simplifies your analysis. It's like you programming, right? You write a function for a whole set of functions. Yeah. So you it's like this function incorporate and all the bundle of functions that you require for a particular task. So you can use it many times instead of you just write every single function inside this function every time. Yeah. So here is the same. For force analysis, there are certain conclusions which we can use to simplify our logical induction every time. So one of the very important one I'm going to show you now is this. For two force member, okay. For two force member, if this member itself only have forces in at the ends, at the two ends, and then it does not have any external torques or external moment, or it does not have any forces in between, okay. Then the forces at the ends will be in axial direction. Okay, this is very easy to analyze. Why? Let's look at this. For example, if this force it does not have any force, this member it does not have any forces in between, or it does not have any moment on this part, okay. If we take any of the end as the point of analysis, okay, we look at the other force acting on the other end, okay. The moment created by this one will make this member rotating, but in fact, most of the cases the member will be in static equilibrium. So, which means this force must not in any other direction other than this axial direction. Okay. Then this one will not create any moment. So that's why the whole member will be in static equilibrium. Okay. But remember, it is the same logic for us to analyze this one. Okay. So if we cover this, okay, all the forces on this point will not create any moment. So we just need to look at the other end, which will have forces which will be able to create moment. So in order to maintain the static equilibrium of this one, which means sigma m equals to 0, okay? Sigma m equals to 0 means this resultant force on the other end must be in the axial direction as well. Yeah. So that's the logic for us to deduce that for member which have only forces at the two ends, the forces at the two ends must be in the axial direction. Okay. But remember the condition. Condition is there's no forces in between, and there's no external torques on this member. Okay. What do I mean by the forces in between? Okay, look at this member again. So if there is a force in between, okay, if we take moment about this point, this one this force will create no moment, but this one will create a moment, okay? And then this one, it will create a moment as well. So as long as the moment created by this one equals to moment created by this one equals to 0, then this one will be in static equilibrium. The same for this point, okay? The moment created by this one, add up the moment created by this one. If it is equal to 0, it will be in static equilibrium here. So in this case, if there are any forces that acting in between, inside this member, between these two ends, this condition, this theorem does not apply. Okay. Another condition is if there's a moment inside this member, okay, which means like this, if one end is fixed into the ground, okay, then if we have one moment over here, if we have forces which is not in x direction at one end, okay, which creates a moment for this whole object to turn in this way, then this external moment can just balance out with this moment created by this force, in axial force. Okay, that's why with these two conditions, external force, external moment, or forces in between the ends, okay, with either one of them, the condition, this theorem does not apply. Okay, this theorem only applies when there's no force or there's no external moment. These are only forces at the ends. Okay, in order to maintain the static equilibrium, the forces must be in axial direction. Okay, this one will be a very important judgment where we can use to do force analysis of all the other components. Okay, it will be very useful for your MP2 as well, because it's all about kinematics and dynamics. You study MP2 to this extent? Kinematics? No.
Next one.
Next time. So maybe you can use this to analyze this, to reconsider some of the logical deduction. Do force analysis one by one. Let's make force analysis about this member BA first. Okay, BA is this one. Okay. For force BD, you find out, right? Is in the member BD, because the deformation is positive, means member BD is under tension, right? So means member BD is under tension. Okay. So for the force which the member BD offers to the rest of the members,